Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
So today we're interviewing Bill Venners, who I have known for, my gosh, more than
97 years.
Well, I think 20 plus years.
Yeah.
It has to be.
Calculate.
25 years maybe.
How did you guys first meet? I don't know if I've heard the story.
Bill knew about thinking in C++, and he didn't Sue tell you should just reach out to me? And then I think you showed up at my house, in my dad's house in La Mesa. That's what I remember.
What I remember is I was working on my first book, which was the JVM one, that Java inside the Java virtual machine. And I looked at thinking in C++, and I thought it was good writing. And so I came up to you after you gave a talk at some, what was the name of those conferences? But I came up to you.
The Software Development Conference.
And I was kind of interested in how you write paragraphs, I think is what was our first meeting. It was, what was the name of the conference?
The Software Development Conference.
Yes, SD, that's right.
Yes.
Software Development. Yeah. That's where it was.
Yeah.
But then we started teaching together. Remember, we did the design class together, and then we decided that we evolved to bike trips together.
Right. So we did that.
And then
I was going to mention spitting the dummy. So we took that. We did that 3 week. It was just you and I. We flew to the South Island of New Zealand, and we were there for 3 weeks, and we rode all around. And those people told us, because we would get up and we would drink coffee and we'd get all jazzed and we'd be talking, and then we would eventually drift apart. And somebody was riding or driving or something, and later they said something to us, and they go, "We thought you'd spit the dummy," and we said, "What the heck does that mean?" And they and we still I don't know how many people who are British or even New Zealander that you've asked about that, and only a few of them know what it means. But when they told us about it, it was like, "Oh yeah, everybody knows this phrase, spit the dummy," and what it means is. So a dummy is like a dummy breast, like a fake breast. So it's a pacifier. And so if you spit out your pacifier, it means you're, mad or angry, you're not having a good time.
Yeah. And you usually start crying.
Yes, there's
crying. We hadn't spit the dummy. We had just, we just like to be in our own space in the afternoon when we're writing. That's what we told them.
Right.
But, we had a wonderful trip over there.
Oh my gosh, that was great. And then we did another one in Europe.
That's right. Yep.
Yeah. Was that along some river?
It was along the Danube. It was between
the Donau.
The Donau? Oh, okay.
No, that's the same thing. But,
Yeah, we went from, I went from Vienna to Budapest. You, I think, rode all the way from Prague to Vienna, didn't you?
I don't remember even more.
Yeah.
Wow.
But,
way back.
It was quite an adventure.
It was a long time ago, and I don't remember the last time I was even in Crested Butte now. It seems like forever.
It does seem like a while
ago.
It is. I think I met you maybe in Crested Butte the first time at one of your conferences that you did with Martin.
Yes, one of the early ones.
Yeah.
Did you come to?
I think so, but maybe not.
Yeah.
I feel like I met you at one of those Martin Bruce conferences a long ago.
With Martin Fowler.
Possibly.
Since we have more than
we've known each other a long time, all of us.
Yeah.
We have.
Well, and I was thinking back to when we started doing Flex stuff, the three of us on Artema. We did some articles and stuff on Artema around Flex. And that was, I think, the time when I started to get to know you a lot better was working on that stuff, I think.
Yeah, because you set up Artema when blogging was still relatively new, and you wanted to create a platform for people to blog on, and lots of people did.
Yeah, that's right.
And then eventually everybody just kind of drifted off to their own
Twitter.
Software. It was the worst software I ever wrote, actually.
Is it still running, though?
Just to keep them up there. They're still there,
Right.
So
I've replaced it.
It can't be the worst ever if it's running 15 years later or something.
That's the thing that's something that I have learned over the time, is that we all complain about, thought leaders or whatnot, complain about how crappy software is and you should do software better. But crappy software like makes a lot of money in production.
Yeah.
I've found, and I'm like, I've seen software that's like just all the horrible things we hear about and talk about, but it's making lots and lots of money in production, and then
And it just works.
Well, no, there's sometimes bugs happen, and then they fix them.
But when was the last time you had to fix a bug in Artima?
Well, we have new software, so we fix bugs all the time. I mean, probably in the matter of like weeks or months ago. But
on Artima.com, on the blog site.
So like there's new software. What I did is let's see, we have Tomcat running kind of in the background to serve up old content that we haven't moved over to the new system. But we like moved all the articles over to the new system. Okay. We didn't move the blog posts over yet. Yeah. So that's, it's all still there. Everything anyone ever wrote is there. And
I migrated my blog recently from WordPress to Hugo. And it was one of those things that I just had put off for years and years. I'm like, I got to just get off WordPress, and, it can be a static site. So I think I originally had tried Jekyll and got like 80% of the way there, and then gave up, and then did the same thing with Hugo. And then like years later, I'm like, okay, I got to get this done. So then I finally like did that last 20% that was, most like 10x the time of the first 80%, and got it all done, got it all running. And I'm like, why did I spend all that time like WordPress was fine. Like I could have just left it on WordPress. But
yeah.
So, and then your Scala book, tell me the title again.
Programming in Scala with an in the middle, because there's also Programming Scala. And there was 2 books called Programming Scala and 1 book called Programming in Scala.
Okay.
Why not Programming with Scala?
There was none of those, but see, that's still available.
Yeah.
Ours was the one with the stairs on the front.
And that it was, you did a second edition of that?
And a third and a fourth, and I'm just finishing the 5th, which will be about Scala 3. And that was like a major rewrite.
That's a big rewrite.
It is a big rewrite. And then we took the opportunity to rewrite because it's a different time. So it's one thing that happened is it split into 2 because it was already a fat book. I can tell you exactly, but it was 800 some odd pages.
Wow.
And, to add more material, because now in Scala 3, one of the things that happened is macros became, like metaprogramming became official, whereas before in Scala 2, it was experimental. So we didn't cover it.
Right.
So I felt first of all, it's really interesting and I want to cover it. But I can't add 200 pages. I mean, I do have 1 book, maybe 2 on my shelf that has 1,000 pages, but that's ridiculous.
Yeah.
So I divided into 2. And so now the programming in Scala is going to have 650 pages, like 150 pages fewer. And then there's a whole second book, which will have 400 odd pages probably.
And that's the metaprogramming. So instead of programming in Scala, it'll be metaprogramming in Scala.
Or advanced. We called it advanced because it is advanced. It's more like library designer kind of stuff.
Yeah.
And it also makes it, I thought our book made Scala look a little intimidating because it's like, oh my God, 800 pages? I don't have time to read 800 pages. So if it's like 600, it's kind of psychological, right? If it's 600 pages, it's just like fat enough to feel like, wow, I can learn a lot, but not, oh my God, So that's sort of, part of it too was just a lot of people don't care about this advanced stuff. And we don't need to clutter up their life with stuff they don't care about. That's really more the domain of people who are writing libraries they use. You use libraries and those people know about the metaprogramming and whatnot.
Yeah.
And you don't have to think about it. So that was kind of
It's funny because Odersky likes to talk about how small the specification for the Scala language is. Yeah. But then if you compare the size of that specification to the size of his book, you're like, okay, there's 2 sides of the story.
Yeah. I mean, in the original Scala, like Scala 2, the grammar was smaller than other languages. Python was smaller.
Huh.
But Python was, Java, C#, they're all really much larger. But in Scala 3, I think, has changed that because he's supporting both Scala 2 and the new syntax.
Yeah.
And so it's gotten a lot more complicated, I think.
Yeah.
So how long, the official Scala 3 just came out like what, a couple weeks ago.
Yeah.
So how long have you been working on this book? It seems like a lot.
Well, the 5th edition I've been working on. Honestly, it kind of was a well timed for me in that when the pandemic hit and I couldn't do travel, so it gave me something to focus on. So for that year, that was my project, most of my main focus. And it was, we went through every single page, everything, and redid not just like the examples, but also the focus, because in 2007. When we were working on this one, Java, like dynamic languages, Python, Ruby was kind of like a craze, and definitely, we were appealing to Java people. And now there's a lot of data scientists who know Python, who don't know Java, who are kind of like only interested in Scala because Spark has Scala, because they want to run data stuff, processing on JVMs, essentially, is what I think draws them. So it's a different audience, and so it's less Java focused. It's also less Java focused in terms of not just examples, but it's more functional. I think when we first wrote this, because functional wasn't in the brain of Java people as much. There are a lot of mutable examples all through this thing because that's what people are familiar with. Well, now
you needed to bridge their knowledge to Scala.
Yes,
and now your focus is not so much on that bridge.
Well, it's a bridge, but the people, it's like a different
people
time.
Have changed, right? So,
like Java got lambdas, and there's streams, and there's map and flat map, and it's just different now. So we changed the emphasis and then just made them a lot more functional, a lot less mutation in there.
Nice. Do all of your examples use the significant indentation?
Yeah.
It's so nice. It
makes it actually,
it looks wonderful.
More concise in the book, actually, because it's less vertical space.
Yeah. Totally.
The closed curly brace, that was what was...
yeah. Think of all the lines that are saved.
Environment, I guess.
But what did you do with the functor syntax? Because that's the thing we ran into. We started working on a Scala 3 book, and then we bailed on that idea, and we'll talk about our new idea in a little bit. But it was the functor syntax. We're like, okay, so we're just only going to reference functions for functors so that we don't have to use braces for them. Was, I think, where we ultimately landed for that. But then we've moved on since. But
yeah,
there is some compiler flag you can turn on, some experimental language change to not use braces on the functors, but
I don't know. I just I did ask Martin. I wanted to show his preferred style, and obviously he prefers this because he was the main person pushing for indentation, sensitive, and it's nice. What like the problem I have is there's an optional end.
Yeah.
And so really I'd like to show that when it's above a certain amount of weight, but sometimes it pushes the example onto the next page, and so I don't. And so I'm like, so that's one thing I'm struggling with. Like I plan to send this to the printer Tuesday.
Oh, really?
Yeah.
Nice.
So that means that week it'll come. It takes me a while to get all the ebooks out, but like within a week, they'll be on Amazon and all that, and you can already buy it in places because it's been announced, the paper book, but like pre-order it. But it's
But now you need to think about page wrapping issues with code and how things wrap. Yeah.
Well, and so that like what and remember that who was the guy that said the medium is the message?
Marshall McLuhan.
Yeah. So I never understood that until I started doing layout for a book, and I, like to get rid of an orphan, which is just like one word at the end of a paragraph, I would rewrite the paragraph. I would change the paragraph. So it's like the medium was forcing me to say something different. And this is, it's the same thing with layout. That is layout. I call that layout process, which we do at the very end.
Yeah.
And so this putting the end, speaking of end, the little end keyword, and it's not just end, it's end, like Ruby has an end at the end,
yep,
which I think is very pretty. Scala has end token. So you have to say end while or end, Fred, class Fred.
What it is that you're ending, yeah.
That's right. So but it does help find an end marker, and kind of visually. And I wanted to show in the book good style, and that's what I'm struggling with right now. Like the last few days is putting ends on things where they don't fit, Anyway, that's
because I'm used to Python, so I don't mind not having ends on things.
Okay, good. Yeah.
And I think we like this, the most compact. I just find the fewer lines that you have in an example, the less intimidating it is. You go, okay, I can stare at this for a while. And like you say, if it goes over to another page, it's kind of like, oh, that's too bad, because then the person has to flip back and forth.
So you aim for not having any code wrapping across pages?
Or? That would, to me, being able to sit and stare at an example without having to turn pages is helpful.
Yep.
So,
well, I try to do that too. Yeah.
Yeah.
The only thing I allowed, I think, in this 5th edition to wrap was some Java code. Sorry.
Well, yeah, but
it's just
that's great.
It wasn't. It's just like, oh, whatever. It was too. Sometimes it's hard, and if it's when you look at in the ebook, of course, you have to flip to the next page. But in the paper book, if it's like bottom and top, you can actually kind of see it.
Right.
If it's open on the same spread.
Just as a joke, you have like 5 pages in the book of Java with getters and setters, just to show how horrible it is.
See, we still compare to Java. I'm trying to remember what that one was about. But there are a few little things. This is, places where we say this is Java. Because Java is still Java. I mean, it's like the 800-pound gorilla.
Yeah.
So it's not like I got rid of all Java.
Yeah, it's important. It's important.
And actually, it's kind of hard to get rid of some of them. And it really is still, a lot of people who read this will be familiar with Java still. So,
yeah.
But I was just going to say, Bruce, that I remember when we were talking about Python a long, long time ago and indentations, and I was thinking that my first thought was, oh, this is great. You don't ever have to argue about, where to put the open curly brace anymore. That solves that. But then I noticed that Guido would say that he can tell if he's working on open source or Google stuff, whether it's two spaces of indentation or 4 spaces. So, of course, in the Scala community, we've had that argument of how many spaces of indentation. And one thing that I notice about Python is it's usually 4.
Mm-hmm.
And that, I think, helps you see that it ends here. And in Scala, we really like 2. But now
then it's harder to visually see.
Yeah, I wonder if that won't change over time, because we're used to 2 because we've had the curly brace to end it. Yeah. And now that people begin to see the meaningful indentation, they might move to 4.
Maybe SPT did it right with 3. 3 is the nice balance.
For a while, Martin put the examples all 3 for a month, and then he changed it back to 2. And so what the other thing people pointed out is Python, and we talked about Python being 4 space indents, and one of the things that people said is it's different. Python is very imperative, do this, do this, do this, where Scala is functional, where you string things together like map, flap, map, map.
Yeah.
Mm-hmm.
And so that was it is different, so anyway, I think it'll be interesting to see what people do with Scala 3 over time.
Mm-hmm.
It's hard to predict where things will land.
So when will people be able to get the book?
Well, they can buy a preprint already, and the official final release will be next week, I think.
Wow.
I'm still waiting for a piece of something that hasn't come in yet that I can't write myself. Mm-hmm. But so I'm hopeful I get that. If I don't get that, I don't know what I'll do exactly. But the plan is Tuesday I send this to the printer, because we got that's what we told them.
Nice. So you've spent quite a bit of time on this over the last year.
Yeah. Yeah, it's the main thing that.
That's cool. Has Martin been pretty involved, or
no? He
mostly
has
been you.
One. So he wrote about half this book originally.
Yeah.
And I think he helped with the other editions, but the last edition.
You had a third co-author on the first one, right?
Yeah, Lex Spoon. Yeah, so Lex didn't this time. This is the first time Lex didn't help. He was too busy. So other than looking at pull requests and whatnot and giving comments, snide comments,
Yeah.
Helpful comments. Like last night or like 2 days ago, he says, "Oh my God, comment." Okay, so another thing that happened, and this is the kind of thing that Bruce and I used to love to talk about. So in Kotlin, you can say comma. You know all Kotlin very well. Like when you say that like something, instead of extends, it's a colon, I think.
Yeah.
And then you just list them at the comma. Like after implements in Java, it's A, comma, B, comma, C. Well, Scala was always with, which is more verbose.
Mm-hmm.
So in Scala 3, you can use commas there, which looks a little bit more like Kotlin. You still say extends, which is like Java. So it's just kind of like Java without the word implements.
What about and? Why not and? Because in the type parameter, it's and, right? Instead of with. Or you can either use and or with in the type parameters.
There's a reason. Ampersand is A and ampersand B is the same type as B ampersand A.
Yeah.
Right? Whereas,
but because of the diamond problem, you have to specify precedence.
Order matters, so it probably should have.
Yeah.
But that thought crossed my mind too. But that's why I think it's good. It's not.
Yeah, that's good. Yeah, because that would violate the algebraic rule of and. So.
In Java, Kotlin, everybody uses commas. It's more concise, so he added that. But there was a nice.
Well, and I guess that the comma implies order, like in a list, and so yeah, that makes sense. I like it.
But there's a anonymous class, what's it called? Anonymous instance expression. I just looked at the name last night. It's like an anonymous class expression where you say new Fred, and that's an interface, you know? You can say new Fred with A with B. Like that actually is something. That doesn't work with commas.
Oh, interesting.
Forevermore, there'll be two ways to do it, which is very unfortunate.
That's unfortunate.
So I'm kind of like, do we really need commas there? That's sort of like my opinion. But on the other hand, what Lex said when he saw that, because I went this like last, 4 days ago, I emailed Martin saying, I was kind of like not so gung-ho about the commas myself, and I left those as widths. And I said, wait a minute, probably he wants commas. So I asked him, and he said yes. So I changed it. It was a real easy change. And Lex saw that. He goes, oh my God, that's so beautiful. We're gonna we're gonna think how do we live without that for so long, without the commas? He really liked it.
Yeah.
So anyway, it's I don't know. I think it's Scala 3 had the straitjacket of compatibility. Yeah. And so what Martin did is to some extent made things better without breaking older ones, which means now it's bigger.
Sure. Yeah. But you're saying that now when you do an inline anonymous inline class, you have to use with. So correct. Now there's an inconsistency.
Yes.
And that can't be fixed?
Well, not anymore. The only way to fix that is not have commas.
Oh, so he couldn't fix it for that case?
No, because imagine you have a list, right? And you want to put in as one of the elements of the lists new A with B with.
You get a parse ambiguity.
Unless you put parens, but I think actually if you put parens around it. Anyway, it's possible it could have been with parens, but that's just hard. People would be upset, I think.
Mm-hmm.
So,
So
my intuition would be just leave with there.
Mm-hmm. So it's consistent.
I like the commas,
Yeah. No, I can see. I guess there's always. I mean, when you create such an experimental language and then you make such a big change, as in Scala 3, there's going to be some compromises. And
you find these corner cases that you didn't think about.
Yeah. It's just the price you pay. So what are your favorite features in Scala 3?
I'm interested in like what's in the advanced book, which I think will be a very fun book to work on because, for example, there's you can track. You can do math on literals at compile time? Well, certainly ints. So I did, in the REPL, I made a list that tracks its length. So I really want to experiment with that stuff a lot. I'm quite interested in that, and it's like what you see in dependently typed languages like Idris. They all have one. List is usually not what they usually do is they call list something that doesn't track its length and vector something that does for some reason. But so I'm interested in that. All the metaprogramming things. I mean, we did a lot of macros in Scala 2, but mostly Qixing did that in Scala test. I delegated that. So I really kind of want to get to know. I myself got interested in type theory through Scala. And so I did a lot of reading of papers and books, about type theory. So I kind of want to keep going in that direction, which is trying to map what's in Scala 3 to the theories, the different kinds of little languages, that research languages people have studied. And I think it's...
we don't really have like value dependent types. I guess you're saying maybe in Scala 3 we can get almost to value dependent types, or...
Well, see, that's the thing. Is like I'm wondering if there's some mapping between those, but I
like at the theory level.
Path-dependent types in Scala are not like regular dependent types, but they do kind of what they do is like if I a path-dependent type involves a type member. So I can take a term like an X and I say dot and then F, or like Fred, and that's a type. Fred is a type. So X dot Fred is like some abstract type that has a name. Fred is the name of that thing. And so I can access it on a term, which is a variable. Yeah. So that's like a value. So it's like this type depends on that value. But the way it's done is because Scala has subtyping is when you pass one of those in, at each call site, it says, okay, what's the actual subtype of X and what type makes sense for that subtype. So, over here, when you're, at the method itself, you don't know what Fred is. It's abstract. But at each call site, it can be something different, something more specific that depends on what's passed in. So that's like not real dependent types.
Yeah.
But it's close in a way. You can kind of achieve some of the same kinds of things. And so then what they added...
Paul Snively and Amanda Locklear did a talk about dependent types a while back at what's the one in St. Louis, the conference there?
Oh, that's Strange Loop.
Strange Loop, yeah. And so they talked about like the four different pieces to dependent types. And I don't remember the talk, but it was awesome.
Yeah.
Path dependent types was one. There was two others that Scala has, and then the value dependent types was the one that Scala didn't really have.
Does not have yet. Well, Martin in the compiler, there's a comment where I watched it. They gave some videos about like walking through the compiler, and there's those four things. It's like types depending on terms, or they call it index by types, index by terms, types by types, terms by terms, and then terms. But say types by terms is the ones that's missing. And he said, but we may have that someday. Just in case we have that, we left that here or something. But but I was going to say that what got added in Scala 3 is literal. Let's see, singleton types for literals. For ints, for example, that's new. What you had in Scala 2 was something called a singleton type, which is a type that has one value in it. Like just unit, for example, is the canonical one. There's just one value. Unit itself is kind of a singleton type because there's just one instance.
Mm-hmm.
But the number 1, the int 1, conceptually is a singleton type, but you couldn't say that in the type system of Scala 2, but you can now in Scala 3. I can say the type of this variable is actually 1. And so the only value has to be 1. So at the type level, I'm tracking an int. And 2 is it's like a subtype of int. 1 is a subtype of int. It's one specific int that just has one instance in it. And so now you can actually say val x colon 1 equals 1. And that type level 1 is you can do math on it.
Yeah.
So if I have, I can actually have a type parameter for my vector, let's say, and it's tracking the length, and it has to be one of these singleton types of an int that happens to be positive, right? And so then when you concatenate two of these, you can add them. Yeah. And like saying, okay, then the new list has this length if you want. So I think that's going to be very fun to toy with. And then there's like multiversal. The only thing I've used so far is multiversal equality, because Scala testing, you're always doing assertions. You're like comparing things for equality. So we wanted to use that to get the type check. So it's a type class called
can equal.
Can equal. Thank you. And so our assertions in Scala 3 just magically start taking that.
That's cool.
Which means Scala test is a mess of if-defs. Essentially, if you're JavaScript, you do this. If you're Scala 3, you do that. And so that's one of the things.
So now with the derived type classes and can equal, that gets cleaned up a lot in Scala test.
Well, no, because we support Scala 2. I mean,
right. Yeah.
And I think we will for a really, really long time, because a lot of people won't upgrade projects, ever.
Yeah. So for our listeners who don't know, you also created Scala test, right?
Yeah.
Which is a fantastic testing library.
Works. But it's been kind of like hard to work on for a while, just because of how big the test matrix is. And there's Scala JS. We support 2.10 to 11 to 12 to 13, and Scala 3 now. Scala JS, JVM, and Scala Native.
Oof. Yeah.
And it's a big code base anyway. And so it's like moving, it's like pushing against a boulder, trying to move it forward. But I think after this book's out, I actually want to spend a few months on Scala tests, because just for fun. And there's a bunch of features that have been like 80% implemented that I want to complete. And, some of that will be exploring new things in Scala 3, like getting can equal used in more assertions.
Yeah.
And, like we never had a differ. I mean, we actually had a differ. Like you can get a diff of case classes if you have but I didn't release it because it used reflection. And I'm like, it seems wrong.
Felt wrong, yeah.
So I'm curious about looking at some Scala 3 metaprogramming features to see if there's
if you can do a better differ.
Maybe we'll just do 3, maybe.
Yeah.
But maybe not. I mean, Scala test is just pragmatic, and so maybe I'll just. But I would like to do something, one or the other, so we have that diffing.
Now, you had a guy in Malaysia, right?
Yeah.
And is that Scala test mostly what he works on?
No, he does most of the work on Scala test the last few years, just because it's so much work. It's like a full-time job. Mm-hmm. But he also does client work when we have contracts, and he does works on the website, and he even worked on the book, like the extraction of examples, like that kind of build stuff. He works on that stuff now. Like he just last night was working on. We added a few chapters. Like we took out chapters that were going to go in advance, and then we added a few, and so those weren't in the examples build. So he does that kind of stuff, and also he's just really a joy to work with. He's worked. He's been with us for I don't know how long time.
And you kind of mentioned that you do Scala consulting. So you have some projects going on currently. Anything
Not
in
many,
Scala?
No. In our pandemic year, that slowed down, which gave me
book time.
Book time, yeah. That's why it was
nice.
Yeah, I had the same experience with the Atomic Kotlin book, because I was able to finish it during the pandemic year, and it was just nice to have something to work on that made you feel normal.
Yeah,
that was my experience. Yeah,
it didn't make me feel normal, but it was nice to have it. Really, I have to say.
Yeah,
and I was at my wife and I were at a stage of our lives where it wasn't such a bad thing. We had a house, and we like each other's company, and we just had a wonderful year together, to be honest. Nice. The main downside for me was my dad. I would have liked to have spent more time with him. So I'm sending the book to the printer on Monday. I'm flying to see him on Tuesday. Monday's a holiday, and then I'm flying to see him on Wednesday for the first time since this all started. It's my first flight.
Wow.
And he suffered just because the timing of the pandemic in his life was really bad because nobody could visit him.
Oh man. Yeah, that's right. So it kind of got impacted in different ways.
Yeah. And I think we're like a little bit irrational now about fear of, like, we're vaccinated and we're still like, I think for a few months we just kind of don't want to do anything anyway.
Yeah. Ease back in slowly.
Yeah.
Yeah, that's true. So, do you have, so you haven't really started working on the advanced?
No, not really. It's in the build, and it has the chapters that were there before. That one I think will be a little bit more like the original one was, where everybody was really like involved in it with the back talk. So Bruce and I talked about back talk, and I think you came up with the name back talk, Bruce. And I think you built a system. So
we did using Zope years ago.
Wow.
I know it was crazy. I actually, Chris, oh no, we use Zope or Plone or one of those things. And Chris McDonough came up here for, I don't know, a week, and we worked on this thing so you could give feedback through web pages or something like that. And now there's other systems that do that, but unfortunately not nearly as universal as one would hope. It'd be nice if you could do it on any page.
Well, we did it in Java.
Right.
Back then. For the original book, that was 2007, 2008, got tons of feedback, and it still works. So we're still getting feedback, and it really is wonderful. I mean, they find typos, they find things that are confusing, just the tiniest little things. They're like not accurate,
Mm-hmm.
So I think that helps the quality of the book a lot, having that interaction. So I'm hoping the advanced book, because that's like really new territory for most people, that will get that kind of enthusiasm. Whereas the plain old programming in Scala, there's a lot of people who know Scala already, and it wasn't like the first time.
Right.
Enthusiasm wasn't like that.
Well, we're planning on putting our book. We're just going to make the Git repo public, so that people will be able to see the chapters as we're developing them and give us feedback through Git. So we're not going to invent a new system for it.
Git is great.
Pull request or
It is great.
Mm-hmm.
Yeah, it'll be a fun experiment.
Yeah, because we're writing it in, we're just using Markdown. And so Git just displays, GitHub just displays Markdown. So it's readable. And that way it'll be, anybody can look at it while it's under development.
So we were going to write Atomic Scala 3, and then we got a little ways into it. And one, we realized that your book was going to be all that anyone ever needed for Scala 3. And then also there was times where I was like, I don't want to show people how to use vars. It's like, that's not what I think they should be doing. And so I don't want to have to write something about all the surface area of the language. I just want to teach people the right way to write Scala. And so we morphed it into being kind of like a ZO Scala 3, a ZO2 and Scala 3 book. And we're having a lot of fun with it.
Yeah. And for me, I felt like I was kind of in a rut explaining all the language features for yet another language. And Bill and James have been big fans of ZO for a while, and it slowly kind of started to seep into my awareness. And I realized, I'm kind of bored with doing just the same old thing with, exploring every feature in a language again. Whereas this is actually really pretty different. And so we decided, we don't need to redo what you're doing. We can just, we can just use only the features we need to use.
Right.
And we can go, and if you want to know all of the other features in Scala, just look at Bill's book. And so it just makes more sense on a lot of levels, and it's much more stimulating, at least for me.
Well, that sounds interesting. I'd like to check that one out.
Yeah, well, it'll be.
And by the way, you meant the other Bill when you said Bill.
That's right, Bill Fraser.
Right. Yes, I was talking Bill Fraser, our other co-author, and we have an intern working on it this summer too. So that's kind of interesting. Yeah. So we're just going to try and look at the kind of the meta level of programming with effects. And just around the whole effects systems, because it does seem pretty revolutionary.
Yeah.
So and quite a different way of thinking about programming and even functional programming. I think it's kind of functional programming provides this foundation, but now we have a system that takes advantage of that without the programmer having to do all the spade work of making that happen. So anyway, I'm finding it pretty fascinating.
Yeah, we're enjoying it.
Oh, so now that you're traveling, you should come to the. We moved the Winter Tech Forum to the summer, so it's now.
When is it?
It'll be in August.
I might.
You should come up for it.
Wait a minute. What in August? I have a wedding in August. But when in August? Do you have a date?
I've forgotten the dates.
We need to memorize these dates.
We need to memorize the dates, and I'm close to getting the website up for it. It'll be summertechforum.com.
Okay. And Summer Tech Forum Unconference.
Right, but the URL is summertechforum.com. But it's the STFU is the
WTF,
which yes, right, because that's what everybody requested. They wanted to call it the STFU.
Yeah.
So so it's the Summer Tech Forum Unconference, but the URL is just summertechforum.com.
We'd love to have you. We'll do some fun Scala 3 stuff.
And
I think I can tell just seeing your backdrop.
Yeah.
That I very much miss Crested Butte, and
yeah.
I do have a wedding that we're going to go to. That's our second trip. It's in New York in August sometime. So
we'll let you know the date.
See if it works.
It could be on the way. Like if it right.
Yeah. Yeah.
And there's also the State Fair, the Indiana State Fair. I want to take my dad to it.
Nice.
That could be a part of this whole grand tour of the United States. Colorado, Indiana, and New York.
There you go.
Possible.
Great. So on metaprogramming in Scala 3, one of the things that I have seen but have not played with yet is in Zio Prelude 2. So it's not out yet. And based on Scala 3 stuff, they're doing refinement types. And the way that they're doing them is pretty cool in that if you have a value at compile time...
Can you explain what a refinement type is first?
Bill could probably explain it better than I can. But so if let's say that you have a value like a user ID, and it's really just a string, but you want to have some type system information that says I'm not just a string, I am a user ID. And so that then it makes it harder for you to screw up passing the wrong thing to a function that takes a user ID, because instead of just taking any old string, which could be, you could give it any string, instead you say, I want to take a user ID. And so then the people who's writing against that function, they get a lot more information from the compiler that says, hey, you're trying to pass this thing and it's not a user ID. But then one of the key parts of refinement types is usually that you'll have some requirements when you construct the type and some validation constraint logic, whatever. And then another piece is that ideally with refinement types, you want the type information to actually go away at runtime or compile out. And so it just is really just a compile time construct. But at runtime, it really is just a string. You don't want the boxing overhead of wrapping it into another class.
So that's the difference between just inheriting from string and adding constructors and constraints.
Or wrapping a string in a case class or something.
Oh, okay.
Yeah. Okay, Bill, tell me what I missed about refinement.
No, that's all right. So in Scala, 2 has something called a refinement type, which is a subtype. So because Scala has I think of the refinement types in type theory as subtypes, but in languages that don't have subtypes, they're just called refinement types. But they're more specific. So like a string is a type, and then user ID is a string. Is a subset of, like, you can think of the set of all possible strings as string. That's like the name of a set.
Yeah.
And then the name of user ID is the set of all possible strings that are valid user IDs, which means they have to start with a letter from A to Z, and they can be at most 10 characters in length or something. There's some predicate that, you can apply that predicate to any string. You can like pass any string to the predicate, and it says true or false. Are you a user ID or not? And so the idea is to have that predicate run at compile time. So it's a compile time predicate. Although you can do it at runtime too, and just give back some or none or something like that, or throw an exception. But it's nice if it's at compile time, maybe.
Yeah.
That's
Zio Prelude. What they're doing with something in metaprogramming in Scala 3 and Zio Prelude 2 with refinement types is, you define your predicates, and if you have the value at compile time, then you get a compile time error if you violate the predicates.
Right, yeah.
I think maybe like a typical refinement type. But then let's say you're getting the value at runtime via a database or something like that. Then what you get back is an option of the thing. Or
right,
there'll be some way to tell you like, hey, this thing didn't meet the constraints of this type construction.
And it's so type still, but it's a some or none.
Yeah. I don't know. Maybe they will use an either or some type so that you can get error information back or something. I don't know. But the nice thing is that it reuses the same predicate definition for both compile time constraints and runtime constraints, and that's enabled through some metaprogramming thing in Scala 3. So
there's something called Scholastic Anyvals, which has been out for like 5 years, which I wrote, and that is that's kind of thing, but it's different. And there's a refined library in
yes
level.
Yeah.
So those are like refined is a like liquid Haskell. That's refinement types in Haskell. Whereas what Anyvals in Scholastic was more object oriented, I thought, which is you actually have a class posint. Like what refined does, and maybe Zio, which I think is very interesting, is actually int such that, x : int such that x is greater than 0. That would be a positive int, right? You actually attach at the type. The type actually kind of includes a predicate.
Yeah.
And they sort of write their predicates at the type level. And that's a dependent type, because I had to say x : int such that x is greater than 0. I keep wanting to make it negative, but x is like a term,
Yeah.
So that's what we did was we said, well, there's just class posint extends anyval, which means you don't box unless you have to.
Yeah.
But there's a predicate, and there's a whole bunch of constructors, and some of them are macros, so that if it's a literal, we can tell it compile time, and it just works.
Nice.
Otherwise, it doesn't compile if it's negative at compile time. But if you can't prove that it's positive at compile time because it's something that's read in from a database or something, then it doesn't let you use that. It doesn't compile either, and it says use one of these other constructors that you can get back an option, you can get back an either,
you
get back an or, you can get back a try. We have a whole bunch of these constructors depending on what you want.
Yeah. That's cool. I haven't used your Scholastic Anyval stuff.
Yeah, so that's it was like, the reason I thought of it that way was because you can then control the methods. So like, for example, posint, and our posint does not have an absolute value method, because that's the same thing as just saying dot value. It'll always be positive anyway. So instead of having two ways to do the same thing, I just got rid of that method. Whereas if you use this refined kind of approach, it will still have whatever method int had.
Yeah.
It will have.
Well, and then there's like the new opaque type aliases in Scala 3, which also another interesting potential piece to this, of being able to hide all that stuff. Hide what you want to from the underlying type.
So what opaque types is another thing I was going to mention, was in Scala 3. So the problem with anyvals in Scala 2 is they can box. I think they only box I think it's worse than that, but I don't really know the details. But like if I had int, then if I put that in a list, it would box to Java-like integer. So if I have a posint and I make a list of posint, it will box to posint. So that's not really a loss, I don't think. But there are times when it'll box that you don't want it. So what an opaque type does is it's always an int. And it will only box when an int would box. So I think it's it's more efficient as far as like avoiding unnecessary boxing than antivals. And then there's one other thing in there, which is when you define an opaque type, I can say it's a subtype of something. So I can say opaque type posint subtype of int equals int. So that at runtime it's an int. But by the way, at compile time, it's a subtype of int, which is really what the other thing we did in antivals is we used implicit conversions to sort of implement subtyping. And this is, I think simpler. It's transitive. Like there's posint is, let's see, which one is that? The positive or zero int, posy int, is a subtype of int conceptually, and posint is a subtype of posy int. Is that right?
Yeah.
Yes, posint is subtype. So you see that?
Yeah.
Like what would be nice is if I could make an implicit conversion from posint to posyint and then another one from posyint to int and have it be transitive, but Scala does not stack those. So I had to make another implicit conversion from posint to int, which works. I mean, we did because it was kind of a finite number. Yeah. But in with opaque types, and that's what I'm thinking in Scholastic, we might have a separate library called opaques. If I wanted to go in that direction, this is what I want to explore.
Yeah,
where we use that subtyping relationship in opaque types to sort of set up this subtype hierarchy of refined,
Yeah. Have you looked at inline classes in Kotlin?
But which ones?
Inline classes in Kotlin. I mean, that sounds like there's some similarities because it's a class, but it's all at compile time.
Okay, I'll have to look at that. No,
yeah, and it's a newer feature. I'm not even sure if it's in the latest version of Kotlin or if it's an upcoming.
I think it's pretty similar to the antivals in Scala.
I'll look at that. I don't remember that one, but I have looked at Kotlin a lot. I like it. I like its syntax, kind of, especially the comma. No, I'm kidding. It's like, man, I wish I could have that comma. Oh wait, I have it.
That's right. Just not in one case.
No, I did. I thought the syntax is kind of elegant for Kotlin.
It is.
Yeah.
No, I've been very happy with it myself. But it doesn't have the things that we're looking at with the ability to support Zio.
Yeah, it's not. It really was the better Java, and Scala had an attitude to promote functional programming, and Kotlin, even though maybe you can try it or do it that way, it's not the same goal. It was my impression, is they were trying to really.
I would call it a much better Java.
plus.
Yeah, for sure. Yeah. But it doesn't.
What's that? That's what plus says, James.
Yeah.
But a much better Java, I think. Yeah, that's a.
Yeah. I think that's what. But I mean, the fact that they decided to compromise with with returning null means failure, or basically, rather than being able to support monads like Scala does.
Yeah,
it's a good compromise for Java programmers and for backwards compatibility with Java. Yep. But at some point you go, wow, it'd be nice to have this better support for.
Well, and they've pretty, I think, stated very clearly that they are not going to go the route of adding like monadic error return types, because that's not their goal. Or not in line with their goal. Whereas their goal really is, in a lot of ways, a better Java.
A better Java with real easy compatibility with Java, which Scala didn't achieve. But
their goal is not melding functional into OO, which leads you on a much different path.
Right. Yeah.
Both of which are valuable.
Yeah. Sure.
For sure.
Yeah.
It is interesting though to see the tension in a lot of those decisions in Kotlin, because I see it come up over and over again where people are like, oh, I want a return type that models the success and failure as a sum, and a SUM. And people are like, nope, that's not how you do it in Kotlin. And I'm like, I get frustrated with that because I want to do it like I do it in Scala. And I see other people like, it seems in some ways like you head down some of these roads, and it does get a little slippery slopey into more heavy functional programming. And then all of a sudden you're into like monads and effect systems, and like, oh God, like how did we get here? And so I can kind of see like Kotlin's resistance to like, all right, we're going to not let you start sliding down that slippery slope.
They made a lot of really conscious decisions around those things. And yeah, I mean, when we were writing the book, Svetlana would say sometimes, she would go, nope, that's not where Scala goes.
That's not where Kotlin goes.
No, sorry, that's not where Kotlin goes. And it was obviously very clear that there had been a decision. It wasn't like they didn't know about these things.
Right.
They did, and they said, no, that doesn't fit. I think the easy compatibility with Java was just, it was very much like what happened with C++. And the backwards compatibility, people look at C++ now and they go, oh, it was badly designed. But no, it wasn't. It was very carefully designed, but it had that constraint of backwards compatibility with C hung around its neck the whole time. And so if you don't understand that, it can look like, why would people make a decision like this? And it was always that. And I think with Kotlin, that easy interaction with Java added some constraints, but in general, I'd say, yeah, it's a successful language, and it's going to continue to be successful. But you can't do some of the things that you can do with Scala for sure.
And you mean Kotlin?
Kotlin can't do some of the things that Scala can do.
Yep,
for sure. So yeah, it's been an interesting trip.
How do you feel about the future of Scala with Scala 3? Do you think there's going to be some kind of reinvigoration of energy into it? Are you hopeful? What are you feeling about it right now?
I think there'll definitely be some reinvigoration of energy, but I also think a lot of people won't upgrade for a very long time just because it's like the payoff is not worth the risk in their estimation. So we need to support Scala 2 for a long time until people are not using it anymore. I think like what this was like my main concern. I was on the advisory board of the Scala Center for a few years now, and that's been I've been like a broken record talking about like migration, and helping people migrate and compatibility and that kind of like.
Whatever happened to the tool that they were working on to make it easier to migrate code from Scala to Scala 3?
Yeah, and
it is Scalafix now, like that. I feel like at one point they were working on their own tool, but now it's just
there's also the compiler itself has a rewrite. You can rewrite it from old like curly braces to indentation,
okay,
things like that, which is pretty amazing. And so anyway,
they've really tried to like make upgradability easier.
Yeah.
But yeah, there's a whole ecosystem that needs to move along.
Well, so there's that story. We should talk a little bit about that because so first of all, one difference between Python and Scala, one thing that's similar is it was 2 and 3. Yeah. So one thing that someone suggested, let's just skip 3 and go to 4. Call it 4. Anyway, so
there aren't drawn parallels between.
Yes. But anyway, the big difference is types, right? So Python 2 code did not have types. Scala 2 code does. So there's a lot more like that you can do to automatically automate this stuff. And also it just reduces the risk that when you port something by hand, if you compile it,
if it compiles it, deploy
it. Well, that's the question. I mean, so then there's just all kinds of attempts at compatibility. So one of them is the standard library of Scala 3.0 is exactly the same standard library, the exact bits as Scala 2.13.
We discovered this in one of our hack sessions for the book. We were like clicked through into a Scala class, and it took us to the Scala 2 standard library. We're like, no, IntelliJ must be wrong. That can't be right. And then we like looked into it. We're like, oh my God, no, it is just the Scala 2 standard library, which is pretty amazing. That
so that's
works.
a big deal, I think.
Yeah.
So Guido, I remember he was blogging on our team, and he said he got rid of an operator. I forget which one it was. But essentially in Scala 3, it's, upgrading from 2.13 to 3.0 is just dealing with the language, not with the standard library to start with. And so that's one thing. And then there's this thing called Tasty, which one of the problems with Scala was, I wouldn't call it problems, features and challenges, is that when you binary compatibility from one release to another. So the way Scala did it is any major, minor point, I think is what we call the third one. So like 3.1.0 and 3.1.1, those are forwards and backwards binary compatible at the compiler level, which means I, as a library person in the ecosystem, I can just compile against 3.1. It doesn't matter which one I use, and people can use it with any 3.1.x. But then when 3.2 comes along, we have to rebuild, so it's a lot more work. So now there's this intermediate. They put in more information in the class files, and it helps that binary compatibility. It makes it a lot better. So that means that you can actually use a library compiled with 2.13 in Scala 3.0.
Yeah,
it works now, whereas it didn't before.
Huh.
And that's just going to, one of the things that's really been a pain point for Scala in industry is, when people have big projects, they end up having 100 dependencies, and it takes forever to get them all upgraded to just the next minor release, like from 2.12 to 2.13 or whatever.
Yeah.
And now that'll be easier because you can mix. You don't have to have them all upgraded.
Nice.
So I think that's a huge improvement, and that's one of the things you get with the Tasty, it's called. So there's a lot of, the compatibility story is pretty strong, but still, if I'm a company and I've got a bunch of big code base, I'm not in a real big hurry to upgrade. Just let other people upgrade, get all the bugs out, whatever.
Yeah.
Listen, hear stories. So it's
maybe when we get to 3.1, that's when there's more real value for people, is when the standard library is rewritten for 3.0 features, right? Like the type classes and type class derivation.
Or libraries come up that you want to use, right? That use those new features in the language too.
Yeah. I think that ZO2 is going to only be Scala 3. But
that makes sense from a library developer's perspective, because it's a pain to support all these different versions. So.
Right. And so our book might be something that helps people be motivated to move to Scala 3.
Yeah. Yep.
Yeah. So it's fun. Mm-hmm. It's I think it's fun times ahead. I'm glad, very thankful for what you've done in the Scala community with Scala Test and Scholastic and your book, and you've definitely taught me a lot. So I'm grateful for that, and look forward to Scala 3 and reading your new book, and hopefully we can get you up here to Crested Butte.
Yeah, I'd love to come join you guys. I really miss you, actually. Now.
Yeah, we miss you too.
Actually, apparently I miss the wall behind you more than you guys, but because I keep talking about that wall and the paintings and the color of the wall.
It is a nice wall. Bruce did a good job on that.
Yeah. But I think it's the pandemic has been. That's one thing I noticed is just how much I miss seeing people at conferences, for example.
Yeah.
Yep.
Running into you in Europe somewhere, wherever it may be. Yeah.
So anyway, we have to do some of that this year.
Yes.
Bill, definitely.
Well, thanks, Bill.
Yeah, it was good.
Really appreciate your time and getting to see you.
Yeah.
I hope you thought to press record.
Oh, darn it.